instead of drawing Lewis structures or Lewis pictures just for atoms, we can also draw them for molecules. So we're talking about the chemical combination of at least two atoms, and those atoms are held together by chemical bonds. The chemical bonds are classified as either ionic or covalent. And an ionic bond comes from a transfer of electrons, and a covalent bond comes from sharing instead of transferring electrons. So the first question when you draw the Lewis structure of a molecule is what type of bonding, and you can tell that from the periodic table based on whether we're talking about a metal with a nonmetal or if we're talking about two nonmetals bonding. So, for example, if we had a metal sodium and a nonmetal chlorine, metals and nonmetals react together by transferring electrons, so this will be ionic bonding. We know that the sodium is in group 1, and that means it has one valence electron. The chlorine, group 17, last digit is 7, that means it has 7 valence electrons. Metals tend to lose electrons and form cations, so the sodium will form a +1 cation because it loses this one electron. It doesn't lose it into thin air, it loses it to the chlorine atom. The chlorine steals that electron away, and the chlorine turns into a chloride anion that now has 8 instead of 7 valence electrons. Notice both of these reach the stability of the noble gases. They reach that octet rule, that group 18. The sodium does it by losing one electron. The chlorine does it by gaining one electron. So this would be our Lewis picture for a metal and a nonmetal. This represents the ionic bond between the two. We don't draw a line connecting them. We just show positive and negative, and we know that positive and negative attract each other, so these two would be held together. If we have a nonmetal and a nonmetal, then the process is a little bit more complicated. What we know is nonmetals are going to share electrons between them instead of transferring. So these steps will let you figure out the correct Lewis picture as long as you follow them in order. Step number 1 is find the skeleton arrangement. Which is just the location of the atoms, and usually you can do this just by symmetry. So for example, if we had a molecule that was made up of 1A and 2B atoms, we could arrange them with the A on the left, B in the middle, and the B on the right. But that's not as symmetrical as putting the A in the middle and the two B's on the outside. So this would be the preferred skeleton arrangement. Step number 2 is count the total number of valence electrons. And it's important that we only count valence electrons, not all of the electrons. If the molecule we're drawing has a charge, we'll have to add one electron for each negative charge. So for example, we have a -2 anion, we were going to add 2 to our count of our valence electrons, and we'll have to subtract one electron for each positive charge that the molecule has. Step 3, connect the outer atom to the central atom. and it requires 2 electrons to make one bond when we do that. Then we satisfy the octet rule for the outer atoms, which are also called terminal atoms. And then step 5, satisfy that octet rule for the central atom. And it's important that you follow that order. So it's always the terminal atoms get satisfied first, central atom gets satisfied second. Step 6, you may not have to do this step, but if it's needed, you'll have to rearrange electron pairs to make multiple bonds. Why would it be needed? It might be needed because you don't have enough electrons to satisfy the octet rule for all the atoms. Step 7, if you have any electrons left over, they're going to go on the central atom. And when you do that, the electrons will always end up being in groups of 2.